Neither NFPA 72 nor NEC 760 explicitly prohibits reusing the same conduit for outgoing and return circuits for a classified detection system. However, there are potential safety concerns to consider. In the event of a conduit or cable cut, both the outgoing and return circuits would be disrupted, rendering the fire detection system in that area inoperable. This could compromise the system's ability to provide early warning of a fire. Additionally, the presence of multiple circuits in a single conduit can increase the risk of electrical interference, which could lead to false alarms or system malfunctions. Classified detection systems provide continuous monitoring of both the outgoing and return circuits. If a fault occurs on either circuit, the system can detect and report it. This allows for early identification of problems and prompt maintenance. If outgoing and return circuits are in the same conduit, the potential benefits of Class A detection are significantly reduced. While it may be technically permissible to reuse the same conduit for outgoing and return circuits, it is generally not recommended due to the safety concerns mentioned above. It is preferable to install outgoing and return circuits in separate conduits to maximize system reliability and maintain the benefits of Class A detection. If the length or routing of the circuits makes it impractical to install them in separate conduits, consider using Class B fire detection systems instead. Class B systems monitor only the outgoing circuits, so a conduit cut would not affect their operation. However, they do not provide the same level of fault detection as Class A systems. Therefore, the decision to reuse conduit for classified detection circuits involves weighing the potential cost savings against the increased risk of system failure and the reduction in the benefits of Class A monitoring. Firstly, let's discuss the purpose of Class A circuits. They are designed to provide a higher level of reliability and fault tolerance compared to Class B circuits. The key feature of a Class A circuit is that it is wired in a loop, originating from the fire alarm control panel, extending through a series of initiating devices, and then returning to the same control panel on a separate conductor. This loop configuration ensures that even if a break occurs in the wiring, the devices on either side of the break can still communicate with the panel. Secondly, the National Electrical Code, or NEC, and NFPA 72, which is the National Fire Alarm and Signaling Code, provide guidelines and requirements for the installation of fire alarm systems. While these codes don't explicitly forbid sharing a conduit for outgoing and return circuits of a Class A system, they emphasize the importance of maintaining circuit integrity and minimizing the risk of system failure. The concern with running both outgoing and return conductors in the same conduit arises from the potential for a single point of failure. For instance, if the conduit is damaged or cut, it could sever both the outgoing and return conductors simultaneously. This would effectively disable the entire circuit protected by that conduit, negating the redundancy that Class A systems are designed to provide. Thirdly, consider the electrical characteristics of the fire alarm circuit. These circuits typically operate at low voltage, often 24 volts direct current. However, they are still subject to the same electrical principles as any other electrical circuit. Sharing a conduit can increase the risk of electromagnetic interference, or EMI, which could disrupt the signal transmission and cause false alarms or communication failures. In addition to EMI, there's also the potential for increased heat buildup within the conduit due to the presence of multiple conductors. This heat can degrade the insulation of the conductors over time, leading to short or other electrical faults. Fourthly, if separate conduits are not feasible due to physical constraints or cost considerations, there are alternative methods to mitigate the risks associated with sharing a conduit. One option is to use a shielded cable for the fire alarm circuit. The shielding helps to reduce EMI and protect the conductors from physical damage. Another option is to install the conductors in a metallic conduit, which provides better physical protection and can also help to reduce EMI. Fifthly, it is crucial to perform thorough testing and commissioning of the fire alarm system after installation, regardless of whether the outgoing and return circuits share a conduit. This testing should include verifying the proper operation of all initiating devices, notification appliances, and the control panel. It should also include simulating fault conditions, such as a break in the wiring, to ensure that the system responds as intended. Sixthly, consider the long-term maintenance and inspection requirements for the fire alarm system. Regular inspection should be conducted to check for any signs of damage to the conduit, wiring, or devices. The system should also be tested periodically to verify its continued functionality. Proper documentation of the system design, installation, and testing is essential for effective maintenance and troubleshooting. Seventhly, it's important to consult with the authority having jurisdiction, or OJ, which is typically the local fire marshal or building inspector, to ensure that the fire alarm system complies with all applicable codes and regulations. The AHJ may have specific requirements or interpretations regarding the use of shared conduits for classes circuits. Eighthly, remember that the primary goal of a fire alarm system is to protect life and property. Any decision regarding the design, installation, or maintenance of the system should be made with this goal in mind. While cost savings may be a factor, they should not compromise the reliability and effectiveness of the system. In summary, while it may be technically permissible to share a conduit for outgoing and return circuits of a classified detection system, it is generally not recommended due to the increased risk of system failure and the potential for reduced performance. If separate conduits are not feasible, alternative methods should be used to mitigate these risks. Thorough testing, regular maintenance, and consultation with the AHA are essential to ensure the continued reliability and effectiveness of the fire alarm system. To further elaborate on the considerations for reusing conduit for class of fire detection systems, let's delve into specific code requirements and best practices. The NEC, specifically Article 760, covers the wiring and installation of fire alarm systems. While it doesn't explicitly prohibit sharing a conduit, it does emphasize the need for circuit integrity and proper conductor separation. Section 760.25 states that fire alarm circuits must be physically separated from other electrical circuits to minimize the possibility of faults or interference. This separation can be achieved by using separate conduits, cable trays, or raceways, or by providing a barrier between the circuits within the same enclosure. NFPA 72 provides more detailed guidance on the design, installation, and maintenance of fire alarm systems. It also emphasizes the importance of circuit integrity and redundancy. Section 12.4 addresses circuit wiring and specifies that classes circuits must be installed in a manner that minimizes the risk of damage or disruption. This includes protecting the wiring from physical damage, environmental factors, and electrical interference. One practical concern with sharing a conduit is the potential for mechanical damage to the conductors during installation or maintenance. When multiple conductors are pulled through a conduit, there is a risk of nicking or scraping the insulation, which can lead to shorts or ground faults. To minimize this risk, it's important to use proper pulling techniques, such as using cable lubricant and avoiding sharp bends in the conduit. Another consideration is the ampacity of the conductors. The NEC specifies the allowable ampacity of conductors based on their size, insulation type, and the ambient temperature. When multiple conductors are installed in a single conduit, the ampacity of each conductor must be derated to account for the increased heat buildup. This derating is necessary to prevent the conductors from overheating and potentially causing a fire. In addition to ampacity, the voltage drop in the conductors must also be considered. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source due to the resistance of the conductors. Excessive voltage drop can cause devices to malfunction or fail to operate properly. To minimize voltage drop, it's important to use conductors of adequate size and to keep the circuit length as short as possible. When sharing a conduit, it's also important to consider the compatibility of the different circuits. For example, it's generally not recommended to run fire alarm circuits in the same conduit as power circuits or data communication circuits. Power circuits can generate significant EMI, which can interfere with the operation of the fire alarm system. Data communication circuits can be susceptible to damage from the high voltage transients that can occur in power circuits. Furthermore, consider the potential for future modifications or additions to the fire alarm system. If the conduit is already full with existing conductors, it may be difficult or impossible to add new conductors without replacing the entire conduit. This can be a significant cost and inconvenience. Therefore, it's often a good idea to install a larger conduit than is initially necessary to allow for future expansion. In summary, reusing conduit for class fire detection systems is a complex issue with both technical and practical considerations. While it may be technically permissible in some cases, it's generally not recommended due to the increased risk of system failure and the potential for reduced performance. Ensuring a conduit is unavoidable, it's essential to take steps to mitigate these risks, such as using shielded cables, metallic conduits, and proper installation techniques. Thorough testing, regular maintenance, and consultation with the AHA are also crucial to ensure the continued reliability and effectiveness of the fire alarm system. When evaluating the suitability of reusing conduit, you should also consider the specific environment in which the fire alarm system is installed. For example, in harsh environments such as industrial facilities or outdoor locations, the risk of damage to the conduit is higher. In these cases, it may be even more important to use separate conduits for the outgoing and return circuits to ensure maximum system reliability. Another factor to consider is the type of initiating devices and notification appliances that are connected to the fire alarm system. Some devices, such as smoke detectors and heat detectors, are more sensitive to voltage drop and electrical interference than others. If these devices are used in a class of circuit that shares a conduit, it may be necessary to take extra precautions to minimize these risks. In addition to the technical considerations, there are also some practical considerations to keep in mind. For example, the cost of installing separate conduits can be significant, especially in large buildings or complex installations. However, the cost of a fire alarm system failure can be even greater, including property damage, business interruption, and potential loss of life. Therefore, it's important to weigh the costs and benefits carefully before making a decision about reusing conduit. Another practical consideration is the availability of qualified personnel to install and maintain the fire alarm system. Fire alarm systems are complex and require specialized knowledge and skills to install and maintain properly. If qualified personnel are not available, it may be necessary to hire a contractor who specializes in fire alarm systems. Finally, it's important to remember that the fire alarm system is only one part of a comprehensive fire safety plan. Other important components of a fire safety plan include fire extinguishers, sprinkler systems, and emergency evacuation procedures. All of these components must work together to provide effective fire protection for the building and its occupants. To further illustrate the importance of these considerations, consider a hypothetical scenario. Imagine a large office building with a class of fire alarm system. The outgoing and return circuits for the system are installed in the same conduit to save money. One day, a construction worker accidentally drills through the conduit while performing renovations in the building. The drill severs both the outgoing and return circuits, disabling the fire alarm system in a large portion of the building. A fire breaks out in the building shortly after the conduit is damaged. Because the fire alarm system is disabled, the occupants of the building are not alerted to the fire in a timely manner. As a result, the fire spreads rapidly, causing significant property damage and injuring several people. In this scenario, the decision to reuse conduit for the fire alarm system had devastating consequences. The cost savings from reusing conduit were far outweighed by the cost of the fire damage and injuries. This scenario highlights the importance of carefully considering all of the risks and benefits before making a decision about reusing conduit for a fire alarm system.